All right, let's try one more question. Same, using solve solve the differential equation using Laplace transform, and this time we are going to do second order equation, but it's very easy, don't worry. Y double prime minus y prime minus 6y equals 0. Of course, we will need two conditions because second order has two constants. That's why it requires two conditions. So we have this one. Right, before we start, of course, we already know that Laplace transform of y of t is capital Y of s. Laplace transform of y prime of t or y prime. Okay, let's just ignore this t. It's obvious that that is there. Okay, y prime is s, capital Y of s minus y of 0. Now we need Laplace of y double prime. Okay, so let us just write the formula for Laplace of double prime. What is the formula for that? Let's put it here. And formula for that is s square y of s minus s small y of 0 minus y prime of 0. As you can see that this y of 0, this y of 0 and this y prime of 0, they are given in the question. So we do not need to worry about these two guys. Capital Y of s is our unknown function which we separate out like this. So capital Y of s, we find capital Y of s and then we take inverse to find y of t. Okay? So first we find capital Y of s and then we take inverse to find y of t, and we use these conditions, these conditions into the solution. All right. So rest of the story is more or less the same. Let's start then. Laplace on y double prime minus y prime minus 6 norm of y prime here equals Laplace of 0. We must take Laplace on both sides. Please remember this part. Never forget it. 6 can go outside. 6 is constant. Laplace of 0 is 0, so that will be 0. Y double prime. So Laplace of y double prime, we now put this formula, s square capital Y of s minus s small y of 0 minus y prime of 0. So that is the first part. Okay, this one, that is this one. Now the second part, y prime, that would be let me drag it a little bit down so that I can write it in one full line. So minus Laplace of y prime. Okay, that is, because there's a minus outside, so I'm going to put a bracket so that we don't make a mistake. S y of s minus y of 0. Okay, so this is minus, because there's a minus here, so that's why I've put a bracket. Minus, again, minus 6 y Laplace of y, which is capital Y of s, and equal to 0. All right, so we know already what is y of 0. It is given in the question. Okay? Y of 0 is 0. Okay? And we also know what is y prime of 0. It is given in the question as 1. Okay? And we also know what is y of 0. So we are going to put these three values into this result. Okay, so this becomes s square capital Y of S minus Y of 0 is 0, so this is 0. This one is 1 minus Sy of S, no need to change because that's unknown function. This will open and this minus will make it plus, okay, minus and minus plus, but Y of 0 is 0, minus 6 Y of S equals 0. Okay? So we have used this one, okay, note, we have used this one, okay, and this one and this one, okay. Capital Y of S is our unknown function, so it's still there. S square, capital Y of S, S, capital Y of S, 6, capital Y of S, minus 1. Do not forget that we have a minus 1 here. This is 0, but we have a minus 1 here, equals 0. Okay. Now we take Y of S common, okay, and we write the rest, S square minus S minus 6. This minus 1 can go on the other side and become plus 1, okay, and become plus 1. Now we can write Y of S equals 1 over S square minus S minus 6, okay. To find our Y of t, we take inverse on both sides, Laplace inverse, 1 over S square minus S. Okay, well, I have done the most part, the difficult part. Now can you complete the Laplace inverse on the right hand side? Pause the video, give it a try. I have done one such question before in the last video, so you can easily do it. Okay, so I hope you have got the answer already. 1 over, can we factorize it, this function? Can we factorize this function? How about minus 3 plus 2? So these are two linears, very easy to solve. Okay, 1 over minus 3 plus 2. So multiply, okay, across, then put S minus 3 equals 0. Luckily these are both linear, so both the constants will be recovered from the values only. 1 equals A times 5 again. That's a lucky instance. You see, the more I don't like it, the more it appears in my questions. Plus B and a 0. So this implies A equals 1 over 5. Such a coincidence. Alright, so S plus 2 equals 0. That means S equals minus 2. 1, A times 0, B times minus 5. Interesting. Both are 5. And that means B equals minus 1 over 5. So our Y of t equals Laplace inverse of 1 by 5 S minus 3. I'll write the direct step. I hope you know already this 1 by 5 comes outside. 1 by 5 comes outside because it's a constant, so it can come outside. And this minus 1 by 5 can also come outside. Minus 1 by 5 Laplace inverse of this is 5. Right, so this will be 1 over e raised power 3t minus 1 over e raised power minus 2t. Of course, there is a 5 here and a 5 here, my favorite. And y of t here. And please note that in this case it is a plus 2 and we have put a minus 2 in each power. I hope you remember this is a minus in the formula and plus 80 in the answer. Okay, so if there's a minus here, we put a plus here, and if it is a plus here, we put a minus here, because in this case a is minus 2. Okay, but in this case a is plus 3, and that completes our answer. And once again, I am sure you can solve this equation without Laplace. Just use any method which we have done, for example, before, and see if you get the same answer. All right.